Question 1. In the context of psychrometric analysis, an HVAC engineer must assess a building's latent and sensible heat loads for an auditorium designed for 300 occupants. Each person contributes approximately 250 B2 of sensible heat and 200 B2 of latent heat. The return air has a dry bulb temperature of 78 degrees and relative humidity of 55%. The outdoor air is 92 for dry bulb and 65 for wet bulb. Which of the following should be the primary focus when selecting cooling coil for this load condition? A. Emphasizing sensible heat ratio to match coil surface temperature. B. Matching the latent heat capacity to total heat gain from occupants. C. Ensuring the dew point of the coil is below return air dry bulb. D. Designing for enthalpy difference across the coil. Answer. Correct answer. B. Explanation. The coil must be selected based on the building's latent and sensible heat gains. With 300 occupants, latent load is significant. 200 B2 x 300 equals 60,000 BU. Coil selection must handle this moisture removal, aligning with ASHRAE guidelines for proper latent heat capacity. Simply matching enthalpy or coil temperature without addressing latent load may result in humid issues. ASHRAE Handbook. Fundamentals. Question 2. Demonstrated by a technician inspecting a low-temperature walk-in freezer. The suction line is covered in frost and compressor superheat measures at 3 degrees. The sight glass is clear, but the evaporator coil shows partial frosting and poor air circulation. Which action should the technician prioritize? A. Add more refrigerant to increase suction pressure. B. Adjust the TXV to reduce refrigerant flow. C. Clean or replace the evaporator fan motor. D. Replace the compressor due to low superheat. Answer. Correct answer. C. Explanation. Low superheat and core frosting suggest excessive refrigerant remaining in the evaporator due to inadequate heat load. Poor air circulation, likely from a failed fan, limits evaporator efficiency. According to the RSES Refrigeration Service Manual, resolving airflow issues must precede refrigerant adjustments. Adding refrigerant or adjusting the TSV can exacerbate flooding. RSES Refrigeration Manual. Question 3. The most significant aspect of designing control systems for a multi-zone valve system is the balance between airflow modulation and system pressure. A facility manager finds that the system's static pressure often exceeds design limits even when most zone dampers are closed. What is the most appropriate solution? A. Increase supply fan speed to ensure pressure at distant zones. B. Install pressure relief dampers in terminal boxes. C. Implement static pressure reset strategy with VFD control. D. Lower the minimum damper position settings for all zones. Answer. Correct answer. C. Explanation. Variable air volume valve systems should utilize static pressure reset controls in conjunction with variable frequency drives VFDs to reduce energy use and prevent overpressurization. ASHRAE 90.1 recommends using static pressure sensors to modulate fan speed to match demand, avoiding unnecessary energy consumption and equipment stress. ASHRAE 90.1. Question 4. Through careful analysis of refrigerant handling violations, a service company was cited for venting R400 TINA into the atmosphere during equipment repair. Which of the following best explains why this practice violates EPA Section 608 regulations? A. R400 TINA is a heavy refrigerant that must be incinerated on site. B. R400 TINA is an HFC and requires reporting under Clean Air Act Section 112. C. Intentional venting of any substitute refrigerant is illegal under EPA rules. D. Venting is only illegal if the system holds more than 50 pounds. Answer. Correct answer. C. Explanation. Section 608 of the Clean Air Act prohibits the intentional venting of all ozone-depleting and substitute refrigerants, including HFCs like R400 TINA. The 2016 EPA Rule 20 CFR Part 82.154 extends venting prohibition beyond SSS to all regulated refrigerants. On-site incineration or size thresholds do not exempt this rule. EPA 40 CFR Part 82 Subpart F. Question 5. Given the circumstances, a service technician measures 240 across. A single-phase compressors run on common terminals, but the compressor doesn't start. Resistance checks show CR equals 60, CS equals 80, and RS equals 14. What conclusion can be drawn? A. The compressor windings are shorted and must be replaced. B. An internal opening exists in the common winding. C. The readings are normal and start components should be checked. D. There is an open winding between run and start terminals. Answer. Correct answer. C. Explanation. The sum of CR and CS equals RS 60 plus 80 equals 14, indicating the windings are intact. The issue likely lies with the start capacitor potential relay or external control circuit. RSES recommends confirming auxiliary start components when ohmic checks confirm winding integrity but motor doesn't start. RSES Electrical Systems Manual. Question 6. While examining a supermarket's parallel compressor rack system, technician Mr. Alvarez notes one compressor frequently cycles off due to high discharge temperature even though suction pressure remains within range. What is the most likely root cause of this symptom? A. Undersized suction accumulator. B. TXV malfunction on individual case. C. Oil separator failure causing oil starvation. D. Overcharge of refrigerant across system. Answer. Correct answer. C. Explanation. High discharge temperature with normal suction often indicates inadequate lubrication, commonly caused by oil separator malfunction in parallel rack systems. Oil return issues cause internal friction and overheating. According to RSES training on rack systems, compressor protection must include proper oil management via separators and reservoir. RSES Advanced Refrigeration Guide. Question 7. From a historical standpoint, walk-in freezer evaporators with electric defroster set to initiate defrost every 6 hours, but recent food spoilage issues prompt a review. If the defrost termination fails, what is the immediate risk? A. Ice blockages on the condenser. B. Excessive frost causing low discharge pressure. C. Evaporator temperature exceeding safe food storage limits. D. Water backflow into the suction line. Answer. Correct answer. C. Explanation. A failed defrost termination switch may allow heaters to stay on, causing evaporator temperatures to rise excessively. This can compromise stored food temperatures, violating food safety standards. The RSES Freezer Design Guide notes the importance of both time and temperature controls during defrost to ensure safe and energy-efficient operation. RSES Commercial Refrigeration. Question 8. To illustrate this point, Mr. Patel is scheduling seasonal maintenance for a rooftop unit serving a hospital's ICU. Which of the following should be the top priority during inspection? A. Checking refrigerant charge using pressure temperature chart. B. Verifying the cleanliness and condition of economizer dampers. C. Cleaning blow wheel and replacing pulleys. D. Ensuring proper function of freestats and safeties. Answer. Correct answer. D. Explanation. In critical spaces like ICUs, freeze protection and safety controls must be verified first to prevent coil damage or patient safety risks. Maintenance priorities differ for healthcare applications per ASHRAE 170 and NFPA 99. General mechanical maintenance is still important but secondary to patient safety features. ASHRAE 170, NFPA 99. Question 9. The growing trend in high-performance duct design emphasizes sealing to minimize leakage. In a retrofit project for a large office, testing shows a total leakage of 20% at 25 par pressure. What is the most appropriate corrective action? A. Replace all ducts with insulated, flexible duct. B. Apply aerosol-based internal sealing to all branch lines. C. Seal all accessible joints using mastic or listed tape. D. Reduce system static pressure to below 0.3 in WC. Answer. Correct answer. C. Explanation. SMACNA and ASHRAE recommend sealing all accessible duct joints using mastic or 180 unwrap tape to reduce leakage to 10%. Aerosol sealing may be helpful, but basic physical sealing is standard and more cost-effective. Static pressure reduction does not solve leakage. SMACNA Duct Leakage Manual. Question 10. Taking into account a building's HVAC energy audit, the engineer finds that 20-ton rooftop unit is running constant 85% load during occupied hours, with 23 degrees temperature difference between return and supply. What efficiency concern arises from this data? A. The unit is oversized and needs to be replaced. B. Excessive delta T indicates refrigerant overcharge. C. Constant high load suggests poor envelope insulation. D. High load factor may indicate undersized system or airflow issues. Answer. Correct answer, D. Explanation. A 20-ton unit running near full capacity indicates possible airflow restriction or poor system sizing. A high DT alone doesn't confirm overcharge. Per ASHRAE Energy Performance Guidelines, sustained high loads with high DT may reveal low airflow across the coil or duct delivery issues. ASHRAE Energy Efficiency Guide. Question 11. In response to a service call, Mr. Gillespie investigates a rooftop unit that intermittently trips the breaker during startup. He observes that the contactor pulls in, but the compressor hums and the breaker opens after about 3 seconds. A capacitor tester shows the start capacitor is out of tolerance. What should Mr. Gillespie do first? A. Replace the compressor and contactor simultaneously. B. Bypass the capacitor and run the compressor without it. C. Replace the start capacitor with a properly rated one. D. Check voltage drop at the transformer secondary. Answer. Correct answer, C. Explanation. A faulty start capacitor prevents the compressor from developing sufficient starting torque, leading to locked rotor current and breaker trip. Replacing the start capacitor with a rated 1 per manufacturer specs is the correct first step. Running without it may damage the compressor. According to NEMA MG1 and RSES electrical guidelines, capacitors must always be within 6% of their rated value. NEMA 1 RSES Electrical Diagnostics. Question 12. When considering refrigerant compatibility, a technician is converting an R22 system to R407. The technician recovers the old refrigerant, replaces the TSSB, and changes the filter dryer. However, the system still shows erratic pressures and poor cooling performance. What is the most likely oversight? A. Failure to evacuate the system to 500 microns. B. Leaving mineral oil in the system instead of switching to PO. C. Overcharging the system based on R22 charge values. D. Using a liquid line sight glass not rated for HFC blends. Answer. Correct answer, B. Explanation. R407 is not miscible with mineral oil, which can restrict oil return and affect heat transfer. Per ARIA manufacturer bulletins, oil must replace mineral oil during HFC conversions. Improper oil results in system inefficiencies, oil logging and compressor failure. Evacuation and sight glass are important but secondary in this scenario. ARI Guideline and RSES Refrigerant Retrofit Guide. Question 13. The effectiveness of using subcooling is a method to charge an air conditioning system depends on several variables. An R400 TINA system shows 13 deg subcooling at the condenser and 18 deg superheat at the evaporator. What does this data suggest about the system's charge? A. Overcharged system with restricted liquid line. B. Properly charged system with stale TXP performance. C. Undercharged system due to low suction pressure. D. Failed EXP causing fluctuating suction superheat. Answer. Correct answer, B. Explanation. Subcooling of 13 deg and superheat of 18 deg are both within recommended ranges for systems using ESBS, typically 1015 deg subcooling and 102 deg superheat. These values indicate correct refrigerant charge and normal operation. Charging by subcooling is recommended for systems with ESBS as per RSES and RE service standards. RSES service procedures, RE 200, 10 or 140. Question 14. By evaluating a high-efficiency condensing gas furnace, Mr. Nguyen observes condensate dripping from the flue pipe's termination during heating operation. The venting is PVC and sloped back toward the furnace. What should he do to comply with code? A. Insulate the flue pipe to prevent condensation. B. Reverse the slope to drain back toward the furnace. C. Repitch the vent pipe to drain condensate away from the furnace. D. Replace the PVC with metal to resist corrosion. Answer. Correct answer, B. Explanation. Condensating condensing furnaces should drain back to the furnace where it is routed to a condensate drain. Per NFPA 54 and manufacturer guidelines, PVC flue pipes must slope toward the appliance 1 inch per foot. External dripping can damage structures and violate venting codes. Metal is not required unless the furnace is non-condensing. NFPA 54 Sec 13543 cease venting practices. Question 15. From multiple perspectives, proper use of a digital vacuum gauge during evacuation is critical to ensure moisture and non-condensables are removed. The technician evacuates a system to 500 microns, but the reading quickly rises to 1500 microns when the pump is isolated. What does this behavior indicate? A. Accurate deep vacuum with minor atmospheric pressure change. B. Internal system leak allowing refrigerant to re-enter. C. Presence of trapped moisture or system leak. D. Faulty micron gauge giving false readings. Answer. Correct answer, C. Explanation. A quick rise in vacuum after isolation is a classic sign of either a leak or moisture boiling off. According to RSES and the CAN evacuation protocols, a standing vacuum test should show stable micron levels for at least 10 minutes. If pressure rises rapidly, the system may still contain moisture or leaks. A CAN manual for RSES evacuation standards. Question 16. Across different scenarios, improper fan speed settings can significantly affect a cooling system's performance. Technician finds that residential air handler is delivering 300 CFM per ton of cooling instead of the recommended 400 CFM. What problem is most likely to develop? A. Excessively high superheat due to reduced airflow. B. Increased latent capacity with lower humidity control. C. Icing of evaporator coil due to low heat load. D. Higher energy efficiency due to lower fan wattage. Answer. Correct answer, C. Explanation. Low airflow reduces heat transfer across the evaporator, causing coil temperatures to drop below freezing, resulting in frost or ice. ASHRAE recommends 400 CFM per ton for proper balance of latent sensible capacity. Airflow below 350 CFM ton typically leads to coil icing and poor dehumidification. ASHRAE fundamentals. RSES airflow diagnostic. Question 17. The core principles of system replacement include adhering to applicable codes. ISTA Martinez replaces a 3-ton R22 system with an R400 TINA system in a commercial strip mall. He reuses the existing line set and connects it to the new system. Post-installation, all return issues are observed. What code or standard has most likely been overlooked? A. Net conduit support for outdoor condensing units. B. IMP duct sealing requirements for return plenums. C. Mechanical code requirement for proper line sizing. D. EPA prohibition on reusing non-flushed R22 line sets. Answer. Correct answer, C. Explanation. The International Mechanical Coding and manufacturers require proper line sizing during refrigerant conversions. R400 TINA operates at high pressures, and improper sizing or oil residue in reused lines can impair oil return. Reuse of line sets is allowed only when confirmed clean and sized correctly. IMC 2021 Sec 1105.6 RE Guideline R. Question 18. The interrelationship between building automation and HVAC efficiency is critical. In a school with a direct digital control (DDC) system, the air handlers constantly operate at full airflow despite room temperatures reaching set points. What is the most probable cause? A. Faulty VFD wiring causing signal interference. B. Improper DDC programming for static pressure reset. C. Compressor short cycling due to oversized capacity. D. Undersized ductwork leading to velocity noise. Answer. Correct answer, B. Explanation. DDC systems control fan speed based on demand via static pressure reset. If programming is incorrect or sensors are misconfigured, fans may not modulate, wasting energy. ASHRAE Guideline 36 recommends optimized sequences of operation to adjust airflow dynamically. ASHRAE Guideline 362021. Question 19. In what ways can leak detection methods differ in effectiveness depending on system configuration? A technician using soap bubbles on a large low-temp freezer fails to identify a leak suspected in an inaccessible evaporator coil. What alternative method would be most effective in this case? A. Use a halide torch around the compressor. B. Pressurize with air and listen for hissing. C. Use a heated diode electronic leak detector near drain pan. D. Apply refrigerant dye and check visually after operation. Answer. Correct answer C. Explanation. In tight, low airflow locations like evaporated drain pans, a heated diode detector is more sensitive than soap bubbles. RSES recommends electronic detectors for inaccessible areas where dye or visual checks are impractical. Listening for leaks is unreliable at low pressures. RSES Leak Detection Manual, EPA 40 CFR Part 82.156. Question 20. Focusing specifically on cooling performance, a rooftop package unit shows 20 undeg DT between return and supply air, but occupants complain of poor comfort. The airflow measures only 320 cm/ton. What does this data most likely indicate? A. Coil bypass factor is too low, allowing overcooling. B. Supply air is not being adequately distributed. C. Latent capacity is compromised by low airflow. D. The unit is oversized for the building load. Answer. Correct answer. C. Explanation. Low airflow reduces latent heat removal, leading to poor humidity control despite a high DT. Occupant discomfort often results from high RHES temperature. ASHRAE guidelines warn against airflow under 350 cfm/ton in humid climates due to reduced dehumidification. ASHRAE fundamentals. A CAM Manual S. Question 21. In the absence of manufacturer startup data, Mr. Thompson is commissioning a semi-hermetic compressor for a medium-temp walk-in cooler. He verifies oil level in the site glass and confirms correct rotation. However, he observes a rapid increase in discharge temperature after 5 minutes of run time. What should he investigate first? A. Blocked condenser airflow. B. Low suction pressure due to a ER restriction. C. Incorrect system charge. D. High ambient temperature, a compressor intake. Answer. Correct answer. B. Explanation. A restricted EXV will reduce refrigerant flow, lowering suction pressure and causing compression ratios and discharge temperatures to rise. Discharge temps above 225 deg threaten oil integrity and motor insulation. RSES compressor diagnostics recommend confirming ESV operation and suction conditions during initial startup. RSES compressor systems guide. Question 22. The development of electrical troubleshooting skills includes understanding the interaction between voltage, current, and resistance. A technician measures 120 across a fan motor, but it doesn't spin. The motor windings test within spec and the capacitor is functional. What is the next best diagnostic step? A. Check voltage under load with motor connected. B. Replace the capacitor again. C. Rewire the motor for high-speed operation. D. Bypass the thermostat to force motor run. Answer. Correct answer. A. Explanation. Measuring voltage across an open terminal can give misleading results. Under load, voltage drop can expose weak connections or faulty controls. According to RSES electrical diagnostics training, underload voltage testing is critical when components appear functional but won't start. RSES electrical troubleshooting manual. Question 23. To better understand pressure control systems, consider Mr. Alvarez's rooftop unit, which short cycles despite maintaining proper refrigerant charge and airflow. The technician suspects faulty low-pressure switch. Which diagnostic method is most appropriate to confirm the issue? A. Jump out the switch permanently and monitor cycling. B. Apply nitrogen pressure and observe response threshold. C. Bypass compressor contactor to test pressure independently. D. Tap into high-pressure side to verify control wiring. Answer. Correct answer. B. Explanation. Applying nitrogen pressure in a controlled environment helps confirm if a low-pressure switch opens or closes at the specified cut-in-cut-out range. This non-destructive method complies with RSES diagnostic standards and maintains safety. Jumping out switches is not acceptable for final verification. RSES controls and safeties guide. Question 24. As illustrated by a residential heat pump that exhibits high head pressure during heating mode, the technician notices that the outdoor coil is heavily frosted, but the defrost board does not initiate. What is the most likely failure point? A. Faulty reversing valve. B. Failed defrost sensor or ambient sensor. C. Undersized indoor blower motor. D. TXV stuck in mid-position. Answer. Correct answer. B. Explanation. If the defrost board fails to initiate despite visible frost, sensors feeding it, coil or ambient, may be out of range. Most boards require both low coil temp and time before triggering. According to RSES training on heat pump diagnostics, sensor failure is more common than board or valve failure. RSES heat pump service manual. Question 25. From a practical standpoint, a technician uses nitrogen and soap bubbles to pressure test a system charged with R448. Despite holding pressure for 30 minutes, the system still loses charge within 24 hours. What advanced leak detection method should be used next? A. Add more nitrogen and repeat pressure test. B. Install Schrader caps with O-rings. C. Use an infrared electronic leak detector during idle hours. D. Isolate each component and weigh refrigerant loss. Answer. Correct answer. C. Explanation. So microleaks escape detection via soap bubbles or standard nitrogen tests, especially under dynamic temperature swings. Infrared detectors can detect ppm level refrigerant leaks, ideal for tight systems like R448 blends. RSES supports use of advanced detectors in critical systems. Assess leak detection procedures. RE Guideline G. Question 26. During the process of defrost cycle evaluation, the walk-in freezer evaporator controlled by time and temperature stays in defrost mode longer than expected. The defrost termination thermostat shows continuity even after coil is above 50°. What should the technician conclude? A. Thermostat is operating correctly. B. Thermostat is stuck closed and needs replacement. C. Defrost clock is out of calibration. D. Defrost heater contactor is shorted. Answer. Correct answer. B. Explanation. If the defrost thermostat stays closed beyond expected termination temperature, typically 50°, the heater will continue unnecessarily, risking temperature spikes. Per RSES refrigeration practices, defrost termination thermostats must be verified with actual coil temperature to confirm performance. RSES Defrost Systems Manual. Question 27. The predominant theory suggests that optimizing system efficiency in variable occupancy buildings requires more than just mechanical upgrades. A school installs co-based demand ventilation controls but notices no energy savings. What likely explains the discrepancy? A. Co-sensors placed in return ducts give inaccurate readings. B. Damper actuators were oversized. C. The valve terminal boxes are improperly sealed. D. Filters with high MERV ratings reduce total airflow. Answer. Correct answer. A. Explanation. Co-sensors placed in return air ducts may average out the concentration, missing localized occupancy spikes. ASHRAE 62.1 recommends placing demand control sensors in occupied zones. Improper placement nullifies potential savings from reduced ventilation loads. ASHRAE 62.1, 2019. See SIS Indoor Air Quality Guide. Question 20. Considering the evidence, a commercial HVAC technician replaces a capillary tube system with a EAO medium temp system. However, the system begins short cycling and suction pressure fluctuates wildly. What may have been overlooked during installation? A. The UTXV bulb was not insulated. B. Capillary tube filter dryer was reused. C. No external equalizer was installed. D. A fixed orifice was left in the liquid line. Answer. Correct answer. C. Explanation. A. Without an external equalizer can misinterpret evaporator pressure, especially in systems with large pressure drops across the coil. This leads to unstable control and cycling. RSES metering device training emphasizes the necessity of equalizers for accurate TSV operation. RSES metering devices manual. Question 29. Contrary to popular belief, increasing blower speed doesn't always enhance comfort. The technician sets a variable speed air handler to its maximum CFM setting to improve cooling. Occupants complain of noise and humidity issues. What error has been made? A. System refrigerant charge is too low for high airflow. B. The duct system was not designed for higher airflow. C. Return grills were closed during testing. D. Supply diffusers were not sealed. Answer. Correct answer. B. Explanation. Increasing blower speed without matching duct design can lead to high velocity noise and poor air mixing. Additionally, high airflow reduces latent capacity, worsening humidity control. ASHRAE duct design standards emphasize airflow balance to avoid these problems. ASHRAE Handbook, HVAC Systems and Equipment. Question 30. The common thread among long-lasting HVAC systems is consistent maintenance. During a 20-ton rooftop unit, technician is Rivera notes. A blackened crankcase heater. The compressor is still operational, but what preventive steps should she take? A. Disable the heater to save energy. B. Replace the heater immediately and log MEGOM test results. C. Monitor oil pressure before making any changes. D. Turn off the unit until heater resistance is tested. Answer. Correct answer. B. Explanation. A failed crankcase heater can allow refrigerant migration into oil during off cycles, causing severe wear at startup. Replacing it during PM avoids compressor damage. RSES preventive maintenance protocols recommend verifying crankcase heaters and logging resistance to trend motor health. RSES preventive maintenance guide.